Welcome to part 2 of the build log for my 1-pound combat robot Blastwave. In case you missed the first video, you should probably watch it because I outline my general plan for this robot. If you skipped it, I'll outline things here. Blastwave is a synthwave inspired combat robot sporting 4-wheel drive and an egg beater spinner. At the beginning of the project, I had CAD files for everything and began by printing the chassis and the wheel hubs. These were pretty good, I could try test fitting things. The motor mount was surprisingly weak though and would need to be strengthened before the final revision. Let's get on the electronics, which is a wild ride. Here was the original plan. An N-Bot's DESC with integrated Lemon RX receiver would be soldered to a naked Turnigy Multi-Star ESC, with both being powered off a wiring harness that connects into the battery with a FingerTech cutoff switch in line. Soldered to the power leads on one of the receiver channels is an LED that N-Bots also sells, to add a bit more illumination to comply with the rules that state that a robot must have a power LED. I chose the N-Bot's DESC because it's light, carrying 2 speed controllers, a mixer, and a receiver in one board weighing in at about 6 grams. The receiver onboard transmits on the DSM-2 protocol, which required a Spectrum transmitter. I chose the DX6E due to its comparatively low cost and future use options. This transmitter allows for onboard mixing and can hold 250 different robots, each named with the channel assignments and mixing saved. This seemed like a relatively future-proof radio, and it was also on sale when I purchased it. Next, I tried to solder the weapon ESC to the DESC. Now, I suck at soldering, and when trying to solder one of the battery wires, I accidentally bridged the positive pad to this capacitor, and nothing I tried could remove the solder, so I simply ordered a model with pre-soldered leads. Now, instead of trying to solder the wires from the weapon ESC directly to the DESC, I ended up soldering separate wires to the DESC and connecting them to the weapon ESC wires. The setup didn't work. To troubleshoot things, I tried plugging it into the electronics for Stompbot. Stompbot is my previous Antweight combat robot, which was built from a guitar pedal because at the time I built it, I couldn't CAD model. I hoped that by using a receiver that was known to work, I'd be able to figure things out, but no. After trying 2 radios and 2 receivers, both of which could control the drive motors, nothing would work. My least favorite thing about the Turnigy ESC is the fact that it has no LED, so there's no way to know if it's even receiving power. Next, I tried running the ESC with my servo tester to see if my receivers were malfunctioning. But alas, even though I could control a servo with it, I still couldn't use the ESC. So I ended up ordering a different model of brushless ESC from Amazon to test things out. This ESC actually worked. This ESC wouldn't actually be going into the final bot, as it weighs more than I had budgeted for, but it still helped by proving that the motors I had worked and that I wasn't going crazy. Speaking of weight budgeting, this is the spreadsheet that I created to help budget the weight for Blastwave. Each component has a quantity required, along with a weight for each of them. The total weight for each type of component is added there on the right, with a total entry for the entire robot down at the bottom. Obviously, a couple things here are missing, like the motor screws and the pulley, but these things won't add up to make Blastwave over the weight limit. It was around this point that I ended up getting some new brushless motors. This was spurred on by the fact that the original Turnigy L2508A motor appeared to be discontinued, so I would be unable to get spares. So after looking around, I came across these, Turnigy Multi-Star Viking motors. They're a bit smaller, lighter, and have the mounting points at the back of the motor rather than at the front, so the mounting solution would need to be redone. Back to the ESC story though. At this time, I was in contact with the seller that I purchased the Multi-Star ESC from, and they agreed to send me a new model. A few days later, and the new ESC came. After wiring everything up, I connected the battery, and things came dangerously close to catching on fire. The battery was hot when I unplugged it, and the boards were toast. The ground wire running from the DESC to the Multi-Star, which was brown for starters, had puffed up and charred significantly. This wire also broke in half shortly after the incident. Also, on the exact opposite side of the board from this wire, the motor leads had completely come off, the solder melting. Okay, that's definitely not good, but what was the cause? The only cause I can think of is that the Multi-Star was defective again, and either had some debris under the heat shrink or some stray solder that shorted the voltage input directly to ground. This makes sense because the Multi-Star was fairly hot after this adventure, and also the ground wire on the ESC was the one puffed up. The only thing that had been changed since my previous test where the DESC worked was the addition of the Multi-Star, which leads me to think there was an issue there. Obviously, this is not a good sign. But let's take a break from electronics woes and get into that hardware stuff. At this point, I just wanted to get this thing driving, and decided to simply use the electronics from Stompbot to get things working. I used these breakout cables to connect 2 motors to each channel of the ESC, screwed the motors in, and connected the wheels. This worked okay. It could drive forward, but it had trouble turning. I was pointed at this potentially being an issue with the wheels being too wide and having too much friction to turn easily. So I decided to purchase some of the FingerTech robotic snap wheels to test this theory. These wheels are much thinner than the BotKit's ones, and use a pretty nifty method of mounting. It is a pretty involved process, and will almost definitely need a second set of hands. First, you attach the hub to the motor shaft with a set screw. Next, you push the foam wheel on over this shaft. Then you put this metal disc over the central part of the hub and push down hard. You have to deform the foam wheel in order to have the disc go low enough. In order to keep the wheel on, we have to use a snap ring. Snap rings are a unique piece of kit that are basically an incomplete ring with 2 little holes on each end of the ring. We use a tool called snap ring pliers to pull the ring apart by inserting the tips into the holes and pulling. We then push this over the end of the hub and insert into this little indentation here. This keeps the disc firmly pushed into the wheel, which helps prevent the hub from simply spinning inside the wheel when under a heavy load. Note that inserting the snap ring is incredibly difficult, and I ended up launching the snap ring several times while trying to install it. Did this work? No. We have all the same problems as before, but I was again pointed to a potential solution. I had wired my breakout cables in series, which gives each motor equal voltage, but I needed to wire them in parallel, which gives the motors equal amperage. I soldered together these new wire connectors, and this worked. Great, now I just needed to get everything else together. Let's get back to the electronics. I was feeling a bit bitten with my ESC situation, and I didn't want to have to purchase several more expensive ESCs, especially as this project had become my most expensive project yet. I had a bunch of Vex MC29 ESCs lying around, and remembered an article by Jameson Go of Team Sawblaze detailing how to modify these into workable combat ESCs. I have the link in the description if you're interested in the technical details, but the basic procedure is this. First, cut the case off. This was most easily done by taking a pair of snips to the corners and working it off from there. You can then cut the wires to an appropriate length and split them. I then chose to solder a male JST connector to the output side of the board to be able to easily connect and disconnect the motors. The next step is to go over to the other side of the board, where the signal ribbon is, and solder another wire to the underside of the ground pin. To one of the ground pins and to the orange wire, I soldered a female JST connector to connect to the battery. The other ground wire and the white signal wire I stripped down and crimped, sliding on a female DuPont connector commonly used for servos. After finishing off by adding a bit of hot glue for strain relief and wrapping the board in electrical tape to prevent shorts, I was ready. I had to buy a new receiver, and since I'd already invested in the DX6Z, I wanted to use that radio. I ended up going with the Lemon RX that N-Bot sells. It's the exact same board as in the DESC I was originally planning to use, plus it's cheap, light, and ships from the US. In terms of a power switch, I continued with the original plan of the FingerTech power switch. I ended up using it as a breakout connector that had 1 female JST for the battery and 3 male JST connectors going to each of the 3 ESCs. Connected to one of the channels was the N-Bot's LED to provide more illumination to comply with the rules. I proceeded to crimp the wires to facilitate easy replacement of the LED should it be damaged. Since the crimp connector I had ordered had some issues staying in, I ended up running a zip tie around the whole assembly to keep everything in, which worked very well. After being burned, almost literally, by the Turnigy Multistar ESC, I decided to try another type of brushless ESC. These Turnigy Plush ESCs were my next choice. They're small, relatively light, and also relatively affordable. Plus, these ESCs have an integrated battery elimination circuit to power the receiver. These ESCs were a bit tricky to set up, but the trick is to make sure that the stick on whatever channel you have it wired to is extremely low at the beginning. I ended up trimming my throttle channel to have the low end at -121, which seemed to make everything consistent at startup. My working theory is that the ESC wants exactly -100 signal, and when it gets a slightly higher value than it's expecting, it gives an error. If it gets a lower value than -100, it can accept it and proceed to start up normally. As previously mentioned, I decided to go with the Turnigy Multistar Viking motors. These motors have threads on the shaft, and there are 2 versions, those with clockwise threads and those with counterclockwise threads. I ended up going with the clockwise version, which should prevent the pulley from backing off when the weapon is spinning. The one issue with this motor is that the wires don't like solder very much. I ended up simply using crimp connectors instead of soldering to get a stronger connection. The motor was attached to this new weapon mount, which, due to its closeness to the wall, required these holes in the side for access to the screws. Let's talk weapons, shall we? The original plan was an egg beater spinner with a pulley in the middle, but that was a slight issue. This isn't an easy thing to machine, and aside from some complex cutting, lathing, and drilling, there wasn't any other way. I could have done a casting, but I couldn't find a good way to do this. The only other option was a metal 3D print from a service like Shapeways, but this was ridiculously expensive. A new weapon design was needed, so I decided to go with a simple drum made from a 3/4 inch aluminum rod. The bar would have a pulley cut into the center of it using a lathe, and would have 4 holes in the side for screws as impactors. I chose this design because one of my friends had access to a lathe, and failing that, there was a local makerspace that also had a lathe. After both of these fell through, the owner of the makerspace hooked us up with a local guy who had a machine shop and let us use his lathe. I didn't get any footage of the actual making of the bar because I didn't want to intrude, being in somebody else's shop and all. We ended up actually getting 2 drums made and 3 pulleys. We took these bare parts home to finish up. I have to thank my brother and teammate Cannon for helping out with the machining of this bar. He did a great job drilling and tapping all the holes. We started by drilling some small pilot holes into the bar before drilling the larger holes into these pilot holes. These holes were then threaded and the bar painted pink. Going to the pulleys, we ended up having issues with the threading. We wanted it to thread on, and we were having trouble finding the correct thread size. In the process of this, we ended up breaking 2 of our 3 pulleys due to incorrect threading, before getting it perfect with the 3rd pulley, threading it with an M4 size tap. The tap was a bit off, again due to hand tools and imperfect drill presses, but it worked well enough. I was originally planning on using a 5mm shaft, as I cat in millimeters, but as I was unable to find a 5mm shaft, I ended up switching to a 3/16 inch steel shaft, which necessitated a search for different bearings. I ended up ordering these bearings. They were a bit thicker than the original bearings, which dictated a size change on the side of the chassis, but this was no big deal. The bigger deal, however, was the issue that the bearings were absolutely horrendous. They were so tight and hard to turn that the weapon bar was unable to even spin up with them installed. Since by this point I had to leave for kilobots within 2 days, I was out of options, and I decided to do the potentially poor idea of running it without bearings, simply set on the print. I used several washers to space the bar out, and after some oiling of both the axle and the belt, the bar actually turned. The issue now was that the pulley would spin off when the bar got up to speed. Apparently I had ordered the wrong thread style on the motor, but no matter. I simply switched 2 of the wires and ran the bot upside down. This worked extremely well, and to remind myself that the bot needed to start upside down, I placed a label on the top to remind myself that I needed to flip the bot over at the start of the match. After wiring everything together, we end up with this spaghetti mess. The receiver is tucked away behind the motor mount, the weapon ESC is tucked behind the motors at the way back, the power LED is glued to the front corner, and the battery is on top of the front motor and the switch taped into place. Everything fit though, tightly woven together into sort of a wire loaf. And that's Blastwave. The final filament color was a bit brighter than desired, but there wasn't a dark enough blue filament that I could find. The pink for the bar color was also a bit darker than desired, but it works for a first revision. In the future, I'd also probably sand the coating off the snap hubs to get it to fit better with the theme, but I didn't have time for that. If you want to see how Blastwave performed at its inaugural event, the 2019 Kilobots Canadian National Championship, be sure to subscribe and stick around, as the event report for that is coming soon, and it'll be linked in the description once it's out. If you want to see the build of my other Antweight combat robot Stompbot built from a guitar pedal, link is also in the description. Thanks for watching, and keep designing.